This is the main control board. Here is the MCU, an STM32F4, no extra memory, so this little guy runs everything. Normally it runs with only one, but during development I'm using two, one here and one here. This part removed, of course, because it's much easier to debug native code, the image analysis part, when it's separated from NetMF. It's possible to do everything under one, but it's easier and more convenient to separate the image part. Actually, there is this new board from Macromint, the Bambino 200, which features an MCU, an XP MCU with two cores. One running NetMF, the other one Mbed, and that sounds pretty exciting. I'm looking forward to do some evaluation on that. Here we have the 4 stepper motor drivers and the LCD display. So everything has been squeezed inside this shoe-size box. Here we have the aquarium pump. One side has been modified to generate vacuum, the other one is pressure. Vacuum is going to the vacuum sensor, then goes through a piece of my wife's clothes stocking to some kind of filter or something. I'm not sure about whether it's very effective though. Here is a homemade switch between vacuum and pressure, so either to suck the part or to expel it, and it goes out here. Below is a stepper motor power supply. Here is the switching power supply for all the logic. Stepper motor drivers, keypad, LCD MCU. Then on the back panel we have 4 stepper motors. Here is the home position sensor for rotation. Here is the ground wire for the magazine EEPROM. The signal, the data, and the power supply is coming from through the needle. Here the vacuum. USB for NetMF to debug a native code, and H232 to connect to the PC to do things like transferring image data to the PC, and so to be able to look at it with Photoshop. Very handy. And here we have a small keypad where we have a forward, backward, right, left, suspend, resume for emergency, up and down, high, low speed, and command button for auto calibration or populating a PCB. And that's it.